Hi students, now we are going to discuss a question given in the Codechef contest started 209. The question name is Easy Grid Game. The question states that we are given a grid of size 2 into 2 containing non-negative elements. Let's say those cells are A, B, C and D. And the question states that each player has to remove one stone in their round, and the next player will have to select a cell which is adjacent to the cell which is previously selected by the previous player, or it can be the same cell which is selected by the previous player. Now I'll give an example. Let's say Alice plays first and she selects C. So Bob has three options. He can either select C, or A, which is adjacent to C, or D, which is adjacent to C. And the question also is given that Alice wants to maximize the total number of stones present on the whole board, and Bob wants to minimize the total number of stones present on the board when the game ends. The game ends when all the cells are 0 or no moves are possible for a player to remove a stone. To solve this question, first we'll have to understand when the game ends. Let's say the current player has chosen to remove a stone from A. So the next player will have three choices. He can remove either from A, B, or C. Let's say if all the cells A, B and C are 0, then the next player cannot have other options to remove a stone, so the game ends there. So from this observation we can say that if B or D is 0, we can force the next player to be playing only on cell A until it becomes 0. We can say that diagonals when any of the diagonal becomes 0, we can force the next player to stay on the same place where until it becomes 0. So the diagonal becoming 0 is really important to minimize the total number of stones left. And the question states that Alice always wants to maximize the total number of stones and Bob wants to minimize the total number of stones when the game ends. So so we can conclude that Bob does not want to make a diagonal zeros, because let's say A and D become 0 and B and C are left. Bob will have to choose either one of them and only can make one cell as 0 and cannot go to another cell. So as Bob always wants to minimize the cells, he does not prefer a diagonal to become 0, so that he cannot reach other cell to reduce them. This observation, we'll see a case where Alice has successfully made a diagonal 0. Let that diagonal be A and D, and B and C are left. So as this diagonal is already 0, as Bob wants to remove more stones from the grid, he will always choose an element, the cell in which there are more number of stones. That is, Bob will choose whichever is a maximum of C comma B, and all the stones will become 0, and the remaining will be the minimum of C comma B, because once he goes here he cannot reach C, so whichever is minimum he cannot reach. This is a really important observation. However, in this case we considered that Alice has successfully removed all the stones in a diagonal, but to reach to reach to a case where a single diagonal is zeros, Alice will take minimum number of moves, that is a plus d. Let's take the same example. Let's say this is a and d. To make these two as 0, we required a plus d moves. So Alice will take a plus d moves to make the diagonal with all zeros. In the meanwhile, as both players play alternatively, Bob will also make few moves. He will make a plus d minus moves, because until a plus d minus moves, he will also try to remove few stones from different cells, but on exact a plus dth move, a diagonal is fixed in which all elements are zeros. So Bob will have a plus d minus moves, and think here, as we can see, once the diagonals are all zeros, Bob will always choose whichever is maximum and remove those elements. But we can see that in the future, when the diagonals become 0, he cannot touch the remaining elements. So before the diagonals become 0, that is until a plus d minus moves, Bob will always try to remove whichever is minimum of from the remaining elements, that is minimum of b comma c. And once the diagonal becomes 0, he will shift to the maximum b comma c. From all these previous observations, we can simplify the problem into a simple formula and determine in which case we can get more number of stones left when the game ends. Let's say Alice starts here, and Alice chose to select the diagonal A and D, that is this one, B and C. So the formula boils down to max of 0 comma minimum of these both, that is B and C, minimum of B comma C minus the total number of steps that Alice takes minus 1. This is if Alice chose to remove the diagonal A comma D, and Alice could also have chosen a different diagonal, that is B2, that could be like this, B comma C. So diagonal 2 would be max of 0 comma min of A comma D minus A plus D minus 1, and we need to return the maximum of these both. Return maximum of D1 comma D2. That's it. The time complexity to solve this problem is order of 1. The space complexity is also order of 1.